load the motherboard in from the front to the back. So I'm going to turn it around so that as I slide it in, it presses up against the I/O shield and all the ports become available. Now, one thing you have to be careful with, there's some little grounding tabs that kind of stick out on these I/O shields, and they can get bent up, and I've seen them actually get like stuck in or inserted into some of the ports here. So you want to make sure that doesn't happen as this presses up here. So I'm going to set this down, kind of push it back, make sure all these connectors are lining up. Oh, I've got a little bit of a problem right there. Okay, this particular I/O shield has holes for two different network cards. I need to bend this one up so that the network card port on this particular board is visible. Okay, now we can try that again. This is lining up. Okay, all the ports seem to be lining up. What I can do now is start putting the first of the screws in. Now I assembled 9 screws from the little hardware bag that came with the case. And one thing I wanted to point out here, notice I'm using a magnetized screwdriver. I think it's a requirement when working on PCs. In fact, Intel recommends it as a way to prevent damage to motherboards, because what will happen is it keeps the screw in the tip of the driver and prevents it from walking out. So a lot of people say you shouldn't use magnetic tools around a computer, and I beg to differ. Magnetic tools make working on a computer, or I consider it a necessity when working on a computer. Doesn't cause any harm to any of the circuitry, so it's not a problem. So now we're going to install all of the screws. Sometimes I like to just start them manually and then use the electric screwdriver to tighten them. I like to get them all just started. A lot easier to get to everything when the power supply and everything is removed. Okay, now if you're a little uncomfortable with the electric, don't hesitate to just use a manual screwdriver. The last thing you want to do is have the screwdriver walk out of the screw and go tracking across the motherboard, cutting traces. So at this point, we now have our motherboard installed in the case, and you want to double check here on the back to make sure all the ports are free and visible, and none of those little grounding tabs have sort of jammed their way into any of the ports or anything like that. And it all looks pretty good. So at this point, our motherboard, processor, and memory are installed. In this series of segments, we're going to build a PC from scratch. Now, I've started by laying out all the components I'm going to use, and let's go over a few tips and tricks before we get started. Now, number one, to do things by the book, you should wear an ESD, electrostatic discharge protective wrist strap. So I'm putting that on here, and I have it connected from my wrist to an anti-static mat onto which I've laid out the motherboard, video card, processor, and RAM. And then another jumper goes from the mat to the case, where I've got it clipped to an unpainted area on the chassis. Now, while I actually build this system in the interest of having things, be viewable better by the camera and in the interest of saving time, I may not use it. But take it from me, it's a good idea to use these components if you're building your own system. These components are these parts are expensive, and you don't want to risk damaging any of them due to a static discharge. Now, if you don't have the wrist strap and such, what you need to do is touch the frame of the case every time you go in to handle something. And if you're going to grab the motherboard or a circuit board that's out of the PC, touch the one of the grounded metal areas, like on the connector shells, or in the case of the card, touch the metal bracket before you pick up the card. And it's best not to touch any of the components. Processors will come with a protective covering, covering the pins or leads, and you want to keep that on until you are ready to install it. So I've got all my parts laid out, everything's ready. A couple of tools that I'm going to need. I basically do almost all of my work with an electric screwdriver. Some people prefer to use a manual screwdriver. That's fine. It just may take a little bit longer. With an electric, you do have to be careful. In some cases, you don't want the bit jumping out of the screw head and, trekking across the motherboard, causing damage and things like that. So that's one thing. Also, if your heatsink doesn't have pre-applied thermal interface material, you're going to need something like this, which is some thermal grease, in order to put on top of the processor to better transmit heat to the heatsink. So other than that, I may need a few other tools here and there, some tweezers to get at jumpers and things like that, but that's it. So let's get started. In this segment, I want to talk about chassis, cooling, and power supply. Now, by chassis, I mean the case that the PC is built in. Now, I've built a lot of PCs, and one of the most difficult decisions I always have when it comes to building a system is selecting the right case. There are so many to choose from, and not a single one has all of the features I look for. So it's always a trade-off. I'm always balancing certain parameters over others to decide what is the best case. Now, this is one that I've actually been using for the last year or two in most of my builds. This is an Enermax Vostok case, and while it's not perfect, it has a lot of good features, but we'll take a look at what's good and bad about cases in general. Now let's discuss first of all cooling, what I think is proper cooling in a case. To have proper cooling, you need more airflow flowing out of the chassis than flows in. So one of the things I look for on the back of a case is a large rear exhaust fan. Now, cooling fans come in 3 different sizes as far as desktop PC cases are concerned. 3 main sizes. We have a 120 millimeter, we have a 92 millimeter, and we have an 80 millimeter. Now, years ago, cases used to come with an 80 millimeter fan in the back, single 80 millimeter fan. That proved to be, not enough. Plus, the fact that smaller fans tend to make more noise. So, in the interest of having both more airflow and quieter PCs, we generally went to 92 millimeter fans or even 120 millimeter fans in the back. I generally won't buy a case unless it has either a 120 or a 92 millimeter rear chassis fan, preferably the 120. Now this is an example of the 120 millimeter fan, and that's what this case came with. And one nice feature about this case is that the fan clips into a bracket that's installed into the case. So the brackets, once the bracket is screwed in, you can easily snap the fan in and out. Being able to take it out quickly and easily makes loading the motherboard a little bit easier. If the fan ever does fail, you can snap in a replacement, very easily. It just literally snaps onto these brackets. So that's one thing to look for. A 120 millimeter fan in the back blowing air out. Now, power supplies also have fans, and the power supply will also exhaust air out the back. So now we've essentially got 2 fans, pulling air from inside the system and exhausting it out the back. Now, where does that air come from? It has to get into the system somewhere. Well, almost all chassis have a vent on the front, and usually it's going to be down below. There's an opening in the front of the front panel, down at the bottom here, where air will go in, and then if I turn this case around, you can actually see where it will flow in through the front of the case here. Now, many chassis like this one not only have just openings there, but there's actually a mount for a secondary fan. Now, one of the features I like about this case is that it can hold a lot of hard drives. 1, 2, 3, 4 hard drives right here, and I can even mount additional hard drives in these 3.5-inch floppy drive bays. So I could actually have a stack of 6 hard drives here if I want. That's a lot of hard drives. And hard drives can, especially when you've got several of them grouped together like this, they can generate a lot of heat. Generally, if I'm installing more than 3 hard drives, if I'm putting 4 or more hard drives in the front of a case like this, I'll want to add the optional front cooling fan. And what that'll do is pull more air in across the drives. So what will happen is the fan on the back will be mounted so that it blows air out the back, but the fan on the front will be mounted so it blows air in. Now the key, what you want to do is make sure you have a balance here. You need more air going out than in. So if I have a 120 millimeter fan on the back blowing air out, I generally like to have a 92 millimeter fan pulling air in on the front. Now, why do you want more air going out than in? Well, because there are other vents on a case. For example, if I show you the side panel for this case, you can see that it has several vents. There's a vent here. This is a vent for the video card. In order to better cool the video card, Intel and other manufacturers came up with the idea of having a vent here so that air can be drawn in. Now, if you have more air blowing into the case than coming out, there's not going to be air drawn in through this vent. It's going to be hot air coming out of it, and that's not what you want. Also, here's a vent for the processor. This is the mark of what's called a thermally advantaged chassis. That's Intel's fancy term for having a processor vent. And what you will find is a duct that's adjustable. You can actually move this in and out in order to get as close or close enough to the processor heatsink, the processor fan, so that it will pull air from the outside. See, the idea is that the air inside the case is heated up. So in order to better cool the processor, we want to draw air directly from the outside to cool the processor. So again, that's why we want more air generally coming out than being blown in, because we want to create a suction. We want to create a vacuum so that air is being taken in through the various vents on the system. So again, what we can do in this, if I'm going to mount 4 or more hard drives, I'll usually take a 92 millimeter fan and mount it up in the front here so that it'll adequately cool all of those hard drives. Okay, you can actually go crazy with fans, and that's something that I don't think is necessary. I rarely build a PC, even a high-performance PC, with more than 2 fans, one in the back, one in the front. Of course, you can consider the fan that's on the heatsink for the processor. That's another fan, and there's one in the power supply. So all told, there are 4 fans in the system, but I'm talking just about the chassis fans. Okay, so the general airflow in the system is going to be from the front, across here, up and out the back, and we're going to be able to cover the motherboard, the processor, video card, through all of the other vents in the system. So from a cooling perspective, this case is very well designed. All right, what other things do we look for in a case? Well, one nice thing to have in a case, which this case doesn't have, is what's called a motherboard tray. That's a removable tray like this, which you would mount the motherboard on, and then insert the mounted motherboard into the case. Having a tray like this makes it a little bit easier to install the processor and heatsink and memory, because you do all that with the motherboard out of the system. If you don't have a motherboard tray like this, then technically you have to put the motherboard in the system before you install the processor and memory, and it can be a little bit difficult because you've got this, the side walls and the bottom and the top, and you can't really see as well. Well, as a compromise, what I've done is I've saved motherboard trays like this one. I've saved from another case that I had discarded years ago. And so what I'll do is I'll temporarily mount the motherboard on this tray, install the processor, memory, heatsink and such, and then I can take it off of the tray and install it in the case, and that makes things a whole lot easier. So that's one little tip there for you. Because unfortunately, finding a case with every single feature you're going to want, like a motherboard tray, is not going to be always possible. All right, what else do we look for? All right, well, this is something that may seem like a good thing, but actually ends up not being that good, and that is these quick-release drive mounting mechanisms. The idea here is that you would be able to, literally turn this, take this off, slide a hard drive in, put this in, and lock it into place that easily. It's a no-tools hard drive mount. Here we have 2 no-tools mounts for optical drives. You can just slide the drive in and quickly latch them in with these plastic attachments. Well, the problem is they don't really mount very securely. They allow the drive to move a little bit, and you end up getting rattles and noise. And without the secure mounting, without screws going in through the case, on either side, you lose a bit of rigidity too. So every time I used to like these kind of things, but anymore I take them out and discard them, and I mount all of the drives with screws. It does take a little bit more time, but I think you end up with a more securely mounted set of drives. The cooling is better because they're more directly attached to the metal of the case, and it just seems to work out better. Now, here's another feature which some may find as a drawback, but I actually think is a bonus. This case is made of very thin metal. It's very lightweight. Now, some people think, oh, I want a heavy case. I used to be in that of that mentality myself. I wanted the thickest steel, heaviest case possible. Well, after carrying enough computers around for years, I've decided that, you know what, a lighter case is better. And that's another reason I like to screw all the drives in. With all of the drives screwed in, the whole rigidity of the case is greatly enhanced. So what was a lightweight case becomes a strong lightweight case. So I'm actually a big fan of the thinner, lighter cases. Yeah, if you drop it, it's going to bend or dent, but you really shouldn't be dropping it. So what else do we look for in a case? Well, this is one of my biggest problems with cases in general, and I think it gives especially novice builders the most trouble, and that is the front panel connections. You know what I'm talking about. I took this off of another case. Most cases have, you have a reset button and a power switch that are mounted on the front, plus you have a hard drive LED and a power LED. How do those things get connected to the motherboard? Well, if you've ever built a PC, I'm sure you've seen these, you have these 4 different connectors. They're 4 little 2-pin connectors. And some of them are polarity sensitive. The ones for the LEDs have to be in the right polarity or the LED won't light up properly. And it's easy to miss pins. Plugging these in is the bane of PC builders everywhere. It causes no end of trouble. You can't see what you're doing, because you have to do this with the motherboard already installed. You can't do it with the motherboard out of the system. Now, if you've ever seen cases from companies like Dell, Gateway, or, in other words, pre-built, mass market PCs, you'll note that they almost always have cases with front panel connections that have a single connector. This is one keyed connector that makes all of those connections at the same time. Now, believe it or not, Intel created a standard for this front panel connector more than 10 years ago. In fact, I think it's like 15 years ago now. And almost all any motherboard that I would ever buy anyway, follows this standard and has this standard type of connector. So the need for these individual pins it's ridiculous. So what I do, in fact, what I did with this case did not come with this connector on it. It came with an arrangement just like this. What I do is I take these individual 2-pin terminals off. I purchase a single 10-pin connector like this. You can buy this from a company called FrontX. That's frontx.com. They sell these individually. You can also buy them in bulk from any electronic supply house. And I simply insert the pins. I don't even have to cut the wires or do anything with the terminals. These are the same terminals that go into this connector, and I simply insert them in this connector in the right sequence and right order, and you find the documentation for that in my book. And then, after just a few minutes of work with this, from that point on, I now have a single front panel connector on my case. So anytime I remove the motherboard or have to plug it back in, it's one single keyed connector, very easy, nothing to mess up. That is a tremendous tip. Also, I look for, this one has a front panel USB connection right here. Make sure that's a single connector like this. In many cases, you'll find those are multiple connectors as well, which is totally unnecessary because that is a standard. And then likewise, here's the audio connection for the front panel. This case has, like many do, speaker or headphone and microphone jack and USB on the front. And motherboards have connections for those. They're an industry standard, so you want a single connector to plug in, not a bunch of little connectors like this. That's a nightmare. All right, so what else do we look for in a case? Well, cases, generally when you buy a case like this case, I believe costs like $50 or $60. The power supply that comes with a case like this, if it does come with a power supply, is usually not necessarily the best type of power supply. For example, I'll note a couple problems with this one. This power supply that came with this case has literally one SATA serial ATA drive power connector. Now I plan on installing 4 hard drives in this case, and I could fit 6. I'm not going to be able to power 4 or 6 hard drives with a single connector like this. Now you can get adapters. Here, for example, I purchased a what's called a Molex 2 serial ATA power adapter, and I can plug that in, and now I have another serial ATA power connector. I guess I could get a couple more and use these, but we simply don't have enough drive connectors, period. There's only 2 more, and I have 4 hard drives plus an optical drive that's going in here. So bottom line, this power supply is inadequate, and I'm probably going to need to replace it before I build a system. So that's one thing to consider. Anytime I buy a case, they generally tend to come with cheap power supplies. I consider that to be a throwaway. Maybe I'll keep it as a spare, be able to use it in another system someday. but I'll probably replace it with something else. Now, when you go to replacement power supplies, you need to make sure that the power supply you're purchasing has the proper connectors for not only the drives you want, like for example, you need, if you're going to install 5 serial ATA drives, you're going to need 5 serial ATA power connectors. You also need to make sure that it has the right main connector for the motherboard. Now this one has a 24-pin connector, which is what most motherboards use today. So that's a good thing. And this one also has the 4-pin CPU power connector. Now the 4-pin CPU power connector is what most motherboards use, but it just so happens the motherboard I'm going to put in this system has an 8-pin CPU power connector. Now you can actually plug the 4-pin into the 8-pin, but if you use a high enough powered processor, it's not going to have adequate power. So what you'll want is to find a power supply like this one. This is a bigger, heavier duty power supply I have on top here. And this one has an 8-pin motherboard CPU power connector. You can see the difference here, 8 pins versus 4. Now you can get adapters to turn the 4-pin into the 8-pin, but that doesn't provide more power. So the idea is that if you need a bunch of adapters to make your power supply work with what you have, you probably don't have an adequate power supply to begin with. So while an adapter here and there is okay, if you start using adapters for everything, it just means you don't have an adequate power supply. Now another thing to look for is many video cards require their own power, and those come in the form of a 6-pin power connector. So this has what is called 2 PCI Express video power connectors, so I can run 2 high-powered video cards. If I was going to do an SLI with 2 video cards running simultaneously, this would be able to power that. So in fact, video cards can be one of the most power-hungry devices in the system. There are some video cards that consume more power than entire motherboards and processors do. So keep that in mind if you need a higher output power supply. Now, I know power supplies are rated in watts, and more watts is better in general. However, not all ratings are the same. Not all manufacturers are honest about their ratings. One of my favorite power supply manufacturers is PC Power and Cooling, and their ratings are rock solid. So when they say it's a 500-watt power supply, that's exactly what you get. I've seen 500-watt power supplies from cheap manufacturers, which I would take a 250-watt power supply over that so-called 500. They're so cheaply made. So we want to make sure we have, as I said, the adequate power to power the motherboard, video card, all of the drives in the system. Now, one point about power supplies. The ATX standard calls for a power supply that's 140 millimeters deep. But there is an auxiliary to that standard that allows the power supply to go as deep as 180 or more millimeters. And this is an example of the deepest type of power supply. These are called EPS power supplies. And as you can see, this power supply would actually fit in this case. I could take this out. The screw holes and everything are identical. 4 screws hold this in. The same 4 screws would hold this one in. The only issue is that I need to make sure that the case is long enough so that the optical drive will fit in the front. And in this case, as in most of them, it actually will. Most of the optical drives are shorter these days anyway, so there's adequate room between the end of the power supply and the optical drive. So that's an issue. If you want to use a really high output, this happens to be a kilowatt, 1,000-watt power supply, probably overkill for most things. But if you have one of these deeper, so-called EPS power supplies, you'll want to make sure that you have room. So that's something to consider there. Now, if you are using a new power supply with an old motherboard, in some cases there are adapters that can handle that. These power supplies typically have 24-pin connectors. As you can see, this type of adapter will adapt it to a 20-pin, which is what the old motherboards used. Now, in many cases, you can actually insert the 24-pin connector into the 20-pin connector on the older motherboard and have 4 pins hang off. They will literally hang out in space and not cause any problems. But in some cases, there are components that interfere. So that's something that you may have to deal with. So with all of these things in mind, we've taken a look at cooling, tips on cooling. We've made sure we've got the right features in our case, and we want to make sure we have adequate power to power the motherboard and the video cards and hard disk drives and everything else we're going to put in the system. In this segment, I want to discuss hard disk drives. Now, in looking at modern hard disk drives for desktop systems, we basically have two main choices today, and most of the time it's not really even much of a choice. In front of me I have two 3.5-inch hard disks. One is of the older parallel ATA configuration, and this one here is of the newer serial ATA configuration. Now, virtually all systems you'd be buying or building today would use serial ATA drives, but I just want to point out a couple of differences and one tip also about the newer serial ATA drives. As you can see with the older parallel drive, the reason it was parallel is because it had a multi-pin connection. It had 16 bits actually of data going down this cable simultaneously, and that was a parallel transfer. On the newer serial ATA, we have only a 7-pin cable, and literally only 1 bit at a time is sent down the wire. So, obviously with the serial ATA, you can see that the cable is much smaller and easier to handle. It's not this wide ribbon cable. But also there's a couple of other differences. One is the power connector is different. Serial ATA drives generally use a different power connector. Now here's one potential problem. Some of the early serial ATA drives actually had both types of power connectors. That is, they had the old Molex type, which is shown here, as well as the new serial ATA. You'd actually see both of them on the back of the drive. If you plug both types of power connectors in, you could literally destroy the drive. So there were warnings about that, and the manufacturers have quickly stopped including the second power connector. I kind of liked it when they did, because oftentimes I was running into power supplies that didn't have the sufficient number of serial ATA power connectors to power all the drives I wanted to put in there. And when the drives had both, no problem. I could use the older style power connector to provide power to the drive. The important thing to note was you just can't plug two power connectors into one drive. That does not work. In fact, it can cause damage. So that's just a warning there. Now, the other problem with the older parallel ATA drives is that you always had to deal with a jumper, or at least almost always. Now, on newer setups, they used a jumper position called cable select, and that means that let the cable decide whether the drive was master or slave. Prior to that, you had to specifically jumper the drive as master or slave. Now, with it set in cable select, when you would plug it into the black connector, like I have here, that would be master, and when you plugged it into the gray connector, shown here, that would be slave. The blue connector on the cable always went to the motherboard. So we had the motherboard connector, slave connector, and master connector. And if you had a cable with the connectors color-coded like that, that's a cable select cable. And then you would jumper the drive in the cable select position. So if you encounter systems, older systems, you're working on them, you need to, install new drives or, repair the system and install a replacement drive, you'll need to be concerned about that. Now, serial ATA drives, they don't have any jumpers, right? It's just a one, connection. There's no master or slave. Well, that's not exactly true. You see, there are two variations of serial ATA drives available. Those that did the original 1.5 gigabit per second speed, and those that do the newer 3 gigabit per second speed. Sometimes those are called SATA 2 drives, which is actually inappropriate terminology. They are technically SATA 3 gigabit per second drives. This is a 3 gigabit per second drive. However, what was discovered was that sometimes if you had an older motherboard that had a 1.5 gigabit connection and you plugged a 3 gigabit drive into it, they wouldn't talk. The drive would not be seen, or it wouldn't work properly. So almost all of the serial ATA 3 gigabit per second drive manufacturers are including a limiting jumper on the drive that will knock the drive down to 1.5 mode. In other words, cut the drive speed in half. And guess what? Virtually all the drives I've seen lately ship with that jumper enabled. So I just bought 6, in fact, of these serial ATA drives. Every single one of them had the limiting jumper in place to knock it down to half the speed. That jumper is, by the way, positioned right here. It's a little tiny gray jumper on this drive. I need to get a tweezers out and take that jumper out, because the motherboard I'm going to be connecting this to will support the 3 gigabit per second rate, and why would I want the drive running at half speed? Most people don't even think about this. They don't know about it. They just install the drive, think everything's okay. So that's something to be concerned about. Now, if you do use a newer drive in an older motherboard and it's not working, then you may need that limiting mode set. So that's something to consider. Now, Since we're almost always using serial ATA drives today, there are actually two different variations of drives that I wanted to talk about. There's, your standard drive, and then there are what are called enterprise or RAID class drives. That's the only kind of drive I buy today. Well, in fact, I normally do install drives in arrays in many of the systems that I build, but even if I'm dealing with an individual drive, I always buy the RAID or enterprise class drive. Why? They are more expensive. They can be 10 to sometimes 20 or 30% more money for the same capacity drive. They're simply more reliable. They have better error correction circuitry built in. They have longer warranties. They're designed to be more durable, more